Welcome back, ladies and gents, to DevOps Pro Europe 2022, the 3-day conference that provides you with the ins and outs of DevOps that you probably didn't even know everything about, because we've got such knowledgeable speakers on a wide array of subjects. And of course, we are now into the third day. If you missed the first 2 days, don't worry, they will be available at a later date for you to watch back, courtesy of you holding a ticket already. And of course, across these sessions, you will not only gather a lot of knowledge, you'll be able to actually bounce back and forth with these speakers on those things via the Q&A sections at the end of each session. So make sure you hang around and make sure any questions you have, you type in during these discussions, and our speakers will take a look at that at the end. But before we do get to our speakers, we do have to give some thanks to our sponsors. Big shout out to Essentia, our golden sponsor. They are a global professional services company providing a broad range of services and solutions in strategy, consulting, digital tech, and operations. TechTree as well, another one of our sponsors, building the first social economic network for devs and their teams with a focus on zero spam and supporting open source. All good stuff right there. And of course, another source of good stuff is Rocket Software, our silver sponsor. With over 70% of the world's IT workload running on legacy platforms, they help companies innovate using the tech they already have, as opposed to those high, expensive costs of upgrading to the newest and latest. And of course, we can't forget you folks. You people at home are what makes this possible. Without you, we couldn't run these events. We wouldn't really be talking to anyone out there. It would just be me and Federico in this case, just nattering back and forth for an hour. So really big shout out to you. And to reward you for your support, we have partnered with Packet, who will be rewarding the most active conference attendees with free ebooks of their choice. To stand a chance of winning, make sure you rate the sessions and leave comments to stand a chance. And of course, Manning's Virtual Tree is also giving you an opportunity to win free books, so be sure to check out their virtual booth. But enough for me, enough of who's been making this event possible. Let's talk about who is going to be fueling this event, who's going to be giving us the knowledge that we seek. Because kicking off our final day, we've got Federico Fregosi here to talk about containers in the cloud. Take it away, Federico.
Thank you, Darren. Thank you very much. And good morning, everyone. Thank you for coming over to my session today. Today's keynote. So just a couple of things before we start and we kick off. Let me share my screen actually, but this will be an advanced level talk. So I will assume some familiarity with a whole bunch of cloud concepts. If I skim through things too quickly, if I don't cover something, feel free to reach out to me at the end of the session. I'm available on the chat. You can always reach out to me. I'll always be there the entire day watching all the other speakers. Let me share my screen now so we can look at the slides together. There you go. It should be perfect. Okay. Perfect. Okay. So who am I? My name is Federico. I work at Contino in London as VP of Engineering for EMEA. I'm responsible for the company's technical strategy, direction of travel, engineering resources. Contino is a large DevOps and cloud transformation company, end-to-end transformation company with offices in the UK, US, Asia Pacific as well. This talk comes from our experience working with large regulated enterprises and taking them to cloud, taking them, helping them using containers, using advanced technologies in the right way. So just a level setting for a moment, a couple of minutes, just to make sure that we all are aligned on this. Why containers? Why people are using containers? Well, all the obvious reasons, I'm sure you'll know about this, but for anybody who may not know about this, containers are a great way to package an application and make it portable across multiple environments. So applications that are running in containers can be deployed easily to multiple operating systems and hardware platforms. Containers increase speed of development, increase the agility. They reduce the operational burden by removing undifferentiated heavy lifting. So containers are very important. They also reduce risk because by uniforming the environments and the uniform security as well, and maintain that with automation. So it's a great way for packaging an application, taking it places, and ensuring a standard level of deployment. People have been building things with container, all sorts of things. We have containers that are used for application development, front-end, back-end, mobile as well. Containers that are getting more and more popular for shared services platform. This is your platform team creating a platform based on containers and offering the platforms to your teams, your development teams in the company. Containers are very used for lift and shift or migration of applications. So you package your application has been running on premises with a whole range of dependencies, Windows or Linux, and you send it to the cloud and you run the application in the cloud. Containers are great for machine learning and data, number of use cases. I'm sure you're all familiar with it. But now, one thing you may not be familiar with is the history of containers. So containers are very, very old technology. This is surprising, but they start in the 1779 with chroot system call introduced in Linux kernel, which allows to change the root directory of a process and its children to a new location on the file system. This is the beginning of what container is. Then we have in 2000 free BSD jails. So 2 decades later, BSD jails are created because hosting providers want to separate different clients co-located on the same machine. So you start creating this. And then we get to 2008. Well, we go through Solaris containers, but we get to 2008, which is a key pivotal moment because we have LXC, the first most complete implementation of Linux container manager. LXC is based upon 2 kernel features. One is namespaces and the other is C groups. It works in Linux without any patches, without anything special. From that point onwards, so 2008, the industry accelerates, explodes really. This is what the industry does. So we have 2013, 2014 as well, Docker and Kubernetes. So Docker is building on a set of features existing. Docker starts saying, okay, I'm gonna take all of that and I'm gonna package it in a way that is very efficient and very easy to use. Containers from your machine onto the cloud, Docker containers, Docker really popularized that. Kubernetes comes right afterwards and comes off need of companies that have lots of microservices running. They have all the systems running. They need to operate these containers. So what happens? We're just going to create a cluster scheduler. Those cluster schedules have been existing for a while in companies. We're always thinking about Google, Borg, which is the project that Kubernetes is based upon. But a lot of companies, large companies, will be operating their own cluster schedulers, form of grid computing as well. There's lots of connections there. And then things accelerate. So 2015, CNCF, Cloud Native Computing Foundation. It's a foundation that aims to standardize and to create the right environment as well. As of today, there are 123 different projects that CNCF supports. In 2015, one more thing happens. So among the 3 big CSPs, Azure, AWS, and GCP, the first container offerings. So there are different ones. So GCP will have GKE, so Kubernetes on GCP. AWS will have ECS, Elastic Container Service, Elastic Compute Service, I think. Elastic Container Service. Okay, so ECS is another one, not based on Kube, but another cluster scheduler. Is a similar use case, operating fleets of containers. Evolution again. So we have a large number of cluster schedulers. Docker adds Swarm as well. There's HashiCorp Nomad starting a bit later. But the industry is converging towards Kubernetes. And so we see more and more Kubernetes-based offerings. All the cloud providers start offering a Kubernetes solution. AWS comes up, Azure comes up. Different solutions running at the same time. The industry evolves, disentangles itself from Docker. So Kubernetes does not rely on Docker anymore, relies on two other projects, Containerd and Cryo. They grow and grow and grow as well. What happens in the past couple of years, I think 2 things. Number one, what I call Kubernetes supremacy, 2020, 2021. And so Kubernetes as a leader in the space, really. And then we have enterprise adoption. So standards, controls, maturity in the space. Most enterprises that we work with right now have a form of Kubernetes offering. This is not new. This is not like we're waking up now. Most enterprises, most large, heavy, regulated enterprises will now operate one or more likely more, Kubernetes clusters. So 2022, what happens now? So I see 3 big trends happening now. Number one, we're maturing in the adoption of Kubernetes, and we're looking at Kubernetes as a way of packaging compute solutions across cloud providers and hybrid. All the CSPs now offer Kubernetes-based offerings that allow you to deploy services across the CSPs, including on-premises. Azure as Arc, GCP as Anthos, which is arguably the most mature, AWS as Outpost, and ECS Anywhere is a number of services that are targeted towards the same use case. Second thing that happens, the CNCF total project sprawl. There are lots of projects that cover a lot of use cases under the CNCF umbrella. This is a problem because it's very hard to understand which ones are the most relevant and most important one for you. You always need this guide. I'm sure you saw the big list of all the CNCF projects, how overwhelming it is. And the third big trend that I see in the industry now is integration with serverless. So whilst all this container revolution was starting in 2014, if I'm not mistaken, but I may be wrong about this, 2014, AWS announced Lambda, which arguably is not the first, but is definitely the popularization of function as a service, serverless solutions. Function as a service has enormous adoption as well. Like lots of small companies, small startups will use a function as a service. Enterprises will start using it as well, more and more and more. So we see this evolution, we see this trend happening. What we don't see often as much is what happens now. Because Lambda has been going. And at some point, and Lambda is the same thing for GCP, Cloud Functions, for GKEs, like it's the same solution. So function as a service has been going for a while and is in parallel with containers. I think that they're merging. They're getting more and more together in an interesting way as well. We'll see. The stock is about this integration that is happening now. So one thing that I want you to think about is the fact that the ecosystem is gigantic right now. So all these applications, you don't just, especially in the Kubernetes, which really is a platform and has this incredible ecosystem of a number of different tools and services that you run on your application clusters, to the point that if you think about one of the most popular projects or systems that you need on Kubernetes is Helm, which allows you to package applications to deploy on the cluster because the specification of the application is so complex that you need a Helm chart to simplify that, right? So this is a big problem because why? Three problems. Number one, it's a significant cognitive load. So it's really hard to operationalize all of this. If you run a platform team and you have a whole number of developers that perhaps are need different applications and different systems on top of Kube, they need to learn a lot. This is a problem because you don't want to increase cognitive load for developers because it will reduce their velocity. Number two is very hard to operationalize. A lot of small components in order necessary to run your clusters. They all have their life cycle. They all have their speed. You need to keep up to date. Cloud providers in Kube will not offer the entirety of the application, but will just offer Kube semi-vanilla. That's a problem. And number three that I see, all of this is not enough. It's not enough. This is a big problem. I did a talk a few months ago talking about developer platforms and exactly about this. And in the talk I had this poll, and most people say that even in large, mature scale-ups, if you want, there are both the benefit of a new architecture, modern architecture, and the agility they inherited from their status of startups. Even those scale-ups, they're still not offering everything a developer may need. So there's a lot of things. All this complexity is the reason why people started building platforms. But it's a challenge in itself because even the people that are building the platform are struggling because the ecosystem changes very quickly. The general problem is, given all these many services in cloud, to run my containers, to build my platform even, which one should I use? Which one should I focus on, right? So the obvious answer, this is a question that a lot of clients ask us, and the obvious answer is it depends. It depends on your use case. Deciding which service to use in cloud depends on your technical skills, depends on compliance, Depends on um, if you need on-premises as well. It depends on too many things, I would argue. And it's a problem. It's a problem because there's too much diversity. This results in typically a framework being created. This is at this point where in the industry gets together and decides, okay, so we're going to apply a generational approach. We're going to say, this was the first generation of container offerings. This is the second. This is the third. But because things have accelerated so quickly, the industry has not created a framework that you can use in your own companies to decide what is the best solution to deploy containers in the cloud for your use case. And it is not like it hasn't been tried. Okay, so AWS has scorecards they're using to help different customers choosing the right container or software cloud compute solution available on AWS. GCP has a whole website dedicated to choosing exactly what is the best or the right container system for you. Azure as well. So there's a number of opportunities out there that cloud providers have been trying to use, a number of activities to standardize this approach. So in my talk, ideally, I would want to give you a framework that you can take away with you and build and choose the right container service in the cloud, whatever that is for you to go and build. There's just a problem. Framework that helps us answering the question, what is the best option to run containers in the cloud, is a complex framework. Takes time to build, takes time to digest, and the decision tree will be so big. So what can I give you in this talk, and what I want to give you in this talk is a bit of a poetic license. So not a general purpose framework, but a list of ideas. So, and one thing, the list of ideas that I will present here will not be complete, will not cover all the use case. They will be useful though, okay? So we're gonna focus now, we're gonna look at options to run containers in the cloud, focusing on a few things. Number one, we focus only on the major CSPs, AWS, Azure, and GCP. We're not gonna focus on the others, not because they're not important, because complexity is too much. We're not going to cover the on-premises and hybrid solution offerings, which are semi in their infancy for sure, and also there's a lot of variability there. They're changing very, very quickly. Adoption is very quick. We're not going to cover obsolete or niche solutions. So we're not going to cover Elastic Beanstalk, which is a great service that AWS has not deprecated yet, but it's definitely not seeing the same marketing and adoption that perhaps Kubernetes service on AWS has. We're not going to look at pure compute, so we're not going to cover running containers on your VMs. We're just going to cover managed services that are running containers for which you can run containers in the cloud. And then we're going to drop the ecosystem view, which is a thing that I was really struggling with when I created this talk, because I wanted to include all the ecosystem view, and give you all the options of where I can run Helm, where should I run Helm. Is there an alternative? It's just too complex. It takes too much time. And we only have 40 more minutes. So this takes way, way too much time. So let me go through the options quickly with you. After having removed all of that, what are we left with? So I think there are 4 broad categories of ways of running containers in the cloud. Number one, web. If you want a web, this is a package service that allows you to run containers in the cloud based for web applications. We're talking about GCP App Engine, AWS App Runner, Azure as well. These services support web application and common concerns, SSL management, CDN, scalability, either running your own container, running directly from the source code, but that's one option of running containers. Number 2, all the cloud providers offer Kubernetes or kube-like cluster schedulers, offerings, GKE, AKS, EKS. Great, but with complexity, especially from an organizational perspective. Creating enterprise policies and deciding how the cluster operates, it's more complicated than it sounds. You need a platform team. Option 3, the most recent one, serverless containers. In this case, we're talking about solutions that allow you to run containers via invocable requests or events. You're priced in different ways per request, per CPU, very similar to Lambda and to serverless. It's a way of extracting away all the infrastructure management so you can focus on what matters the most, whilst retaining, and this is the key piece, whilst retaining a common layer based on Kubernetes. So all the serverless offerings from CSPs are based on Kubernetes. Number 4, raw containers. So it's a way of running containers in the cloud as building blocks. Container instances on Azure, AWS Fargate, run your container as a building block. This is something that is typically used as part of something else. But people have been using Fargate as well on its own to run a one-off job, one-off activity. So these are the 4 high-level categories we're going to focus on in this talk. But this is the ones that I hope you will think about throughout the talk. One thing that I will say, there are definitely more options than this, so way more options than this, but these are the most relevant, the most commonly used one, the most likely important for you to think about. And then we have a slide that talks about how they differ.
Federico,
Excuse
me. Sorry, your camera turned off. I don't know if that was intentional.
Oh,
I just noticed
really?
that. Yeah, just thought I'd let you know. Sorry
Oh,
about that.
thanks. I'm not sure if I'm supposed to do anything.
It should be at the bottom of your.
Yeah, I mean, I didn't disable it. I tried to.
Oh, okay.
Turn it off and on. It's on. I can see myself here. Shall I try to reload the website?
You could try that quickly. We got a little bit of time.
Sorry, folks.
Apologies, folks. All right, he should be back in a second. Apologies for that, folks. Which you mentioned that the camera wasn't shown, and seeing as it wasn't intended, we just want to make sure we sort it now in case something else tripped up as well. Yeah, better safe than sorry, right? Rather have the whole thing working than slowly losing parts of him, just having kind of a Mr. Stark, I don't feel too good moment. So hopefully he'll be back in a second. Apologies for that.
Hello, I'm back.
Hello. There we go. We see you, Federico. All right,
Okay,
wonderful.
Perfect. Sorry,
So,
I had to.
if you just reshare your screen, it should. I'll let you get back to it because I don't want to interrupt your flow too much more than I already have.
Perfect. Sorry about this, folks. Like I had to restart Chrome, as you can imagine. All right. So let me just share my screen. Let me get back to the slides. Okay. There you go. Okay, perfect. So we were talking about our shared responsibility model. So just gonna quickly go back to it. Let's go to the slides quickly. So shared responsibility model, this slide here. Perfect. So this is a bit of a heavy slide. We're gonna spend a minute on it. You can see here something that you manage and something that the cloud provider manages. None of this is surprising. I'm sure you saw shared responsibility models for a while now. There are 2 things that I think will be relevant in this slide for you, thinking about the various options to running the containers. Number 1, authorization and policies. This is a key, often overlooked piece. Authorization and policies. If you do it within Kubernetes RBAC, you're floating on Kube the activities of running your policies. Great. Yeah, you can do that. But then you lose the opportunity of leveraging the IAM of the cloud providers. We need to separate authentication and authorization today. So authentication will still happen through IAM, but then what pods can run on the cluster, what kind of applications you can deploy, do you need a signature to deploy that application, and all of this is effectively offloaded into Kubernetes RBAC, which can be a problem because you have then to manage that as well and stay separate from cloud provider management level. And the second piece as well is management of scaling and load balancing. Scaling and load balancing is more than it sounds. So lot of ways of managing load balancing, and a small scale, maybe I'm fine with whatever. Maybe at a small scale, I'm fine with Fargate forcing me into using the to front my containers with a load balancer. But at scale, I want maybe more than that. Maybe I want traffic shaping policies. Maybe I want to do a complex A/B testing, feature flagging. All of this can be another hindrance, because if the cloud provider, if the service forces you towards a specific type of load balancer, then you have challenges for sure. Okay, perfect. This is it's kind of like a high level view I want to spend a few minutes on with you in this. We'll go now to what I think is the most interesting part of the talk, which is looking at the actual options available on the cloud providers and doing a sort of comparison. Comparison is definitely not going to be perfect. It's going to be opinionated. There's a number of comparisons available online. This is, I've tried to make it as up-to-date as possible, so you will have a view on this as well. And hopefully it will be useful for you. Let's start with AWS. First service, AWS Fargate. So once again, Fargate is the answer to the question, how do I run my container? I just want to run my container. AWS take it from me. AWS does it. The service has grown massively over the years, threefold. It's very, very powerful. Interesting to think about how AWS thinks about Fargate. Thinks about Fargate as not a service in isolation, but service as EC2 in the stack. What it means that as EC2 is a building block for Elastic Beanstalk, Fargate is a building block for a number of other services, to the point that ECS, you can, when you're running Elastic Container Service, ECS, you can choose different fleets of your nodes, and you can choose where to launch your task. You can launch your task on on nodes that you manage yourself, or you can have AWS taking care of that. Most people will say, if I'm running ECS, I'm just going to give it to Fargate, and Fargate will run the container for me. I lose something, as I said, maybe I'm forced into using ALBs. I lose some flexibility with this, but it's very, very, very powerful, and it's one of the most commonly used services. Number two, AWS ECS, Elastic Container Service, launched in 2014, if I'm not mistaken. It's a kube-like service, a cluster scheduler that is built on AWS for AWS. Is the building block of a number of other services on the cloud provider as well. It is tightly integrated with AWS ecosystem as well. So in not only the AWS ecosystem, but a number of other third-party services will know how to supply and serve ECS. We're thinking about Datadog, we're thinking about Sumo Logic, all the SaaS and various applications that can just integrate. ECS has a strong hybrid offering with ECS Anywhere, and it has been Kubernetes-ized. Is that a word? So it's becoming more Kubernetes. One of the examples is some of the recent features deployed that were added to ECS, for example, is ECS exec feature that allows you to interact with running containers, really matches kube control exec. But it's very, very easy to use, very easy to manage, easy to learn as well, control plane. It has even advanced features, so it has traffic management features available with shifting mechanisms. So it's a very powerful service. And then you have EKS. EKS manage Kubernetes experience with manage or self-managed node groups. Managed node groups managed by AWS, self-managed node groups managed by you. Once again, very well integrated with AWS ecosystem, 3 nines and a half of SLA. It has interesting the way in which authentication and authorization are managed. Authentication on EKS cluster, either AWS IAM or OpenID Connect. Authorization on an EKS cluster, kubeRBAC. Highly reliable, very, very powerful. One of the interesting features is the AWS controllers for Kube. Now, what is that? That is a very interesting feature that the other cloud providers will have as well. It helps you thinking about deploying your resources in a consistent way. So if you're deploying an application, you typically don't only deploy the compute components in the cluster. You deploy a database. You deploy a database on RDS. In the CI/CD, most commonly you will have a Terraform module of some sort that will allow you to deploy a Kubernetes cluster, deploy a database by itself, then some connection with the application, and maybe telling, okay, so this is a variable of where database is and everything. But you have two systems effectively to deploy code and infrastructure. One is Terraform, the other is the cluster. The other is the CI/CD for the application and the cluster. AWS controllers for Kube allow you to create and define custom resources that can be deployed with your application to Kubernetes, and then Kubernetes converts the custom resource into AWS infrastructure. This is a way of saying you can create a YAML file that describes your database, your RDS database. Kube control apply the YAML file onto the cluster, and then the operator in the cluster will create a database for you. So you can manage the life cycle of the application and the infrastructure that supports the application within the cloud provider in your YAML description of the application. It's a very powerful feature. Now, by the way, EKS supports very advanced features as well. So we're thinking about multi-cluster service discoverability and support with AWS Cloud Map, and also form of service mesh with App Mesh on AWS. It's a very powerful feature. The way to think about deciding between ECS and EKS is basically deciding what platform you want to use. If you're going all in on AWS, which is a valuable choice depending on your circumstances, then ECS is to be thought about as AWS as a platform. EKS, Kubernetes as a platform. Okay, so this is how to think about that. And then the first and last option we're going to look at on AWS is App Runner. This is a very new service that was launched in 2021 that provides a highly abstracted and simple managed experience for running web applications and API hosting services. What it is very similar to Elastic Beanstalk or Heroku if you want as well, but takes care of more things. So it's very similar to I just want to run my containers, but there's a limitation to this as well. In the same way in which most services will allow you to get of the web category, will allow you to get from source code to deployed application or container to deployed application. So the App Runner supports both. You get granular pricing as well per invocation. And you get a whole bunch of deployment benefits by default. So deployments are immutable and blue and green by default. Scaling is automatic, up and down. There's a workload isolation as well as a feature in its own environment. Observability is very strong because it's integrated within AWS ecosystem. A whole range of benefits of running, but we'll see this towards the end as well. Probably App Runner, in my view, is best suited for web applications so that are deployed there and maybe not running your entire container, but directly from the source code. But if you just have a web app, it's very, very good. Okay, Azure, option 2. Number 1 on Azure Container Instances, response to Fargate or similar to Fargate, based on, I think, on Hyper-V, is a different technology. So supports Windows and Linux containers. Compared to Fargate, it supports container groups, which are collections of containers. Very, very powerful. A container group is a collection of containers that you co-schedule on the same machine. Containers in a container group share life cycle, resources, local network, storage volumes. It's very similar to a pod, if you think about it. It's a pod in container instances. Supports persistent storage with Azure files as well. Number of connections as well. So it's very tight Azure ecosystem as well. So once again, think about this as a building block for others as well. So it's a great solution if you want to run a one-off activity or, as I said, as a building block. But if you want to run long-running, stable workloads or something that requires clever traffic shifting, this is not the right service. Just to tell you, if you think about container instances in isolation, it would not support zero downtime deployment. So You need it for something specific. Option 2 on Azure is AKS, Azure Container Services. Managed Kubernetes Service. It is remarkably similar to EKS. There's a bit of cost difference, but the idea for all the Kubernetes services is that if you want to run them at a consistent scale, in other words, with the same SLA, you can just you pay in the same amount pretty much. Very, very similar. If you want the same SLA, if you want different SLAs, then Azure becomes cheaper. It's still highly reliable as a regional service as well. One significant limitation that it has Azure Service Operators, custom resources, but one significant limitation of Azure AKS against AWS is the size of the node pools. So the limits on the node pools. So right now you can only have multiple node pools on AKS. At the time of this recording are only in preview, so they're not generally available. It's also the size. So AWS EKS supports 13,000 nodes to a maximum, and AKS allows a maximum of 1,000 nodes. So Azure and AWS and this are very different targets. And also whether AWS in the ecosystem offers managed Prometheus solution to monitor your applications and the state of your cluster. Azure doesn't, and you need to go to Azure Monitor for this. So it's a very, very similar service, comparable with a number of other things. Then we have App Service, which matches Fargate, fully managed, built-in deployments with a number of advanced features. So it integrates with Azure AD, so you can have it fronting your application in Azure AD and offloading authentication back to Azure AD. Very powerful, dynamic as well. You don't need to create a lot of code, custom code in your application. Offers a wide selection of languages and granular pricing. It allows you to run custom containers. This is the key. This is why it's here. My view is more mature. It's a service that Azure has rebranded and changed over the years. It sees high adoption. It's one of the core services as well. You can see performance and health of your application with both Azure Monitor and Application Insights on Azure, which is a powerful feature that allows you to see exactly how your application behaves. So it's a very, very powerful service. Don't get me wrong. What I wanted to say is it allows you to deploy source code or containers. In my experience, typically Windows Shop or Microsoft Shops will use a lifecycle, will use this a lot, especially because it's very easy to deploy to app service through Visual Studio. So it's a very tightly integrated ecosystem. And then there's an interesting service, which is Azure Container Apps. It's a very recent service. It's still in preview. This is a service that we're talking about. Fully managed serverless containers at scale for building and deploying modern web applications. So microservices, public API endpoints, even background processing, event-driven processing as well. It's a very simple deployment flow, robust auto-scaling capabilities, so you can scale down to 0. So you can scale your container request down to 0, then you have a cold start problem, or scale to 1, you pay an idle rate, scales up and down fully automatically, based upon Kubernetes. So very, very powerful service. The way in which you think about this, think about container apps as app service for microservices. So fully managed hosting for web applications, including websites and web APIs. So interesting. So it has a couple of features I want to draw your attention to, which I found very interesting. So number one, KIDA. KIDA is a way of managing auto-scaling in a Kubernetes cluster that is fully integrated with container apps based upon different sources. In this case, KIDA allows you to scale based on the size of a queue. So if you have an event bus on Azure or a long queue there, then KIDA will scale your cluster consistently in order to match the load. The bigger the queue becomes, the more containers you're running, the more you can manage and reduce the size of the queue. So very, very powerful. It's a number of other sources as well. It allows you to scale not only on request or invocation, but on some other custom metric. And the other one, another interesting thing, is DAPR or Dapper. So This is a very powerful, this is an even more powerful feature and a very interesting one. So it's an open source project, once again, allows you to integrate with your application with standard services using configuration rather than code. What is the example? If you have a microservice and you want to read or send messages to an event bus or service bus queue in Azure, you would typically import the SDK in your microservice application and talk with the service. With Dapper, you can, rather than doing this, you can configure in configuration the need, you can define in the configuration the need for a queue. And then your application, rather than talking with service bus directly, can talk with a sidecar container co-hosted, so in the same part of the same pod, and exchange messages with the sidecar container. And what it means that you can simplify a lot of the concerns and the common concerns that you need to know about application development. So you can just talk with the application sidecar next to it. It's a very, very powerful feature. You think about this, you can use it for a number of interactions as well, metrics. You can think about this for CDN, for advanced features as well. It's a very, very powerful thing. As I said, it's an open source project. If you haven't looked at that, take a look at it. It's very interesting. Azure Container Apps, by default, immutable deployments, ingress with standard features, traffic shaping, blue and green, environments as well, define isolation and observability boundaries. How to think about this, how to think about Azure Container Apps, and we'll see Cloud Run in a moment. This fills the gap between Azure Kubernetes services and container instances. There's a gap in here. So if you want too simple, container instances is too simple, Kubernetes is too much for me, what do? Azure Container Services is an opinionated view on Kubernetes that caters to 80% of the use cases that Kubernetes is used for. Very, very powerful. The fact that is built upon open source should allow for relative ease of portabilities of applications. We'll see complex applications are tough, but it's nonetheless a step in the right direction, I think. GCP. Google Kubernetes Engine. The oldest managed Kubernetes offering in the group supports managed or self-managed or managed node groups. And in GCP language, we call it autopilot. My view is way more feature complete than EKS or AKS, even if EKS is really going in the right direction. It's the only service that allows you to deploy Istio and manage Istio for you with the cluster. So you flag Istio. Not exactly fully Istio, not exactly fully Istio. There's some limitations, like tiny limitations on this. Supports binary authentication, which is a feature that should not be overlooked. Binary authentication allows you to control what type of applications you can run in the cluster. But in order for you to do that, you need to, you can do that by specifying policies outside the cluster. So you can control which applications are running in the cluster through policies that are native in GCP land, which is very powerful, as I said, so you have everything in one place. GKE is also very tightly integrated with Security Command Center in GCP, and so you have all the benefits of running your applications there and monitor your application for compliance and controls as well. Very similar features to the others, but one interesting offer that stands out for me is Anthos Marketplace. So GCP Marketplace for Anthos lets you manage production-grade application and third-party softwares by clicking and deploying in an Anthos managed cluster, typically GKE. So you can deploy custom apps through a marketplace in your Kubernetes cluster with one click. And then you get a single bill for everything. Updates are managed. You can have direct access to partner support as well. It's a very, very interesting feature as well. Will be probably adopted by others as well. And then we have GCP Cloud Run, launched in 2019, very similar to Azure Container Apps. So managed serverless solution for containers based on Knative, very microservices focused, immutable revisions. So Cloud Run is, once again, does the same thing, stands between running your container bare bones GKE, offering an opinionated, simplified view on GKE, effectively, that allows you to abstract away a lot of Kubernetes complexity whilst relying on GKE. Knative does more than this. Knative allows you to do more than just running the container. You can run source code. It's very interesting. Project in itself is an open source project in itself. Cloud Run, I think, for our purposes, is to focus on containers. So it's a serverless platform, if you think about this. It has robust auto scaling down to 0, allows you to quickly scale, manage bursty traffic as well. You're paying by CPU, so you're paying for a CPU allocated to the container services, and you're paying for when you're receiving a request and it's managed. You're paying when the instance is up. It's a dual pricing model that says you can scale to 0 and pay nothing, but if you're scaling down to 0, then you have a cold start problem, or you can run a reduced idle, you can run a container without any response and paying an idle, very low idle rate. It supports jobs, is a recent feature as well. Jobs is a way of running background processing as well. It is interestingly multi-threaded, so it can handle multiple requests on the same container. It supports HTTP only invocation, so it doesn't support invocation through the queue, but in pub/sub land, in GCP land, the queue, in most common queue system, pub/sub allows you to push. So you can configure pub/sub to push the event to an HTTP endpoint, and so trigger Cloud Run with that. The service was launched in 2019. In 2019, it wasn't as feature complete as you probably want it to be, especially because it was limiting the number of system calls you can make. The cold start times were significant. By the way, cold start times, which are as significant as Fargate container instances, they have significant cold start when you're launching a container for the first time. But the second generation of Cloud Run instead solves a whole bunch of problems: faster CPU, and finally full Linux compatibility. Supports for all system calls and namespaces. Like, there's a lot of features there that are just covered as well. Interestingly, there are 2 versions of Cloud Run. Number one, one version of Cloud Run is fully managed, so you just run your container with Cloud Run, so you don't touch anything on the underlying infrastructure. Version 2 is a version in which you're deploying Cloud Run in your Kubernetes cluster, in your GKE cluster, or any Anthos, but your GKE cluster, and then you can start integrating things. This is a very powerful feature because it allows you to deploy and participate in the service mesh as well. So you can connect the applications as well and discover them, Cloud Run, GKE. You can put everything in one platform as well. One last feature I want to mention: identity-aware proxy. So you can deploy identity-aware proxy fronting Cloud Run or App Engine, and this service allows you to front your application and provide for authentication through G Suite and GCP native services. App Engine, now last service of our excursus. App Engine is one of the oldest services on GCP, focused on modern web applications, fully managed, serverless. It allows for automatic scaling, not immediate. There are some issues reported. Familiar development tools. Is based on VM, App Engine. It comes in 2 versions, I think. One version is fully managed, and the other standard, and the other is flexible. In the standard version, you deploy your source code onto App Engine. In the flexible version, you rather deploy your container to App Engine. Now, what is my view of this? As I said for the other web services of this category, with all the other services offerings available, I'm not sure how much sense it makes to deploy flexible on this. So takeaways of the session, the last few minutes before Q&A. So if you have any questions, by the way, it's the right time to start thinking about the question, maybe writing that down in the chat. Takeaways: container deployment stages. We've seen containers that in most companies, this doesn't hold true for all companies of all sizes, but if you think about most companies, containers were deployed in a lot of ways, and we have this complexity curve that goes up and down, and responds to this. We deploy containers as a single entity. At the beginning of containers history, we just deployed one Docker container, one machine, made in production. We were very happy. But then we realized it was not feature complete. We needed to run 2 or 3 containers. So we ended up deploying with manually orchestrated container services, Ansible, Puppet, Chef, anybody out there still using it. And then this responded to cluster schedulers, because we need to run too many containers, because microservices is a thing, Kubernetes that wins. Manage Kubernetes services to reduce complexity, but then the ecosystem explodes. Then complexity is still there. So we come with an opinionated view on how to run containers in Kubernetes. And these are the new serverless-based offering for containers, which I would really encourage you to think about. So we understood that. Running containers in the cloud, we can position ourselves at different levels of abstractions. We can start with raw containers, VM, and everything. We understood that there's a wide variety of services, starting from web services, that allows us to run containers in the cloud, and they're tightly integrated with the cloud providers, which means you don't choose a service to run your containers in cloud in isolation. You choose the ecosystem that the cloud providers offers. For sure. Ease of management, login, availability, scalability, they're all features that are connected to this. We understood as well that in 2022, running Kubernetes the hard way is probably not as powerful, because we have so many managed services offerings that allow us to remove this undifferentiated heavy lifting. It was really, really powerful. And we understood that you can go all the way down in Kubernetes, all the way up. So one thing to notice in this is the fact that this new serverless containers offering, the big promise of these technologies, is that they provide an identical developer experience to that of Kubernetes. So developers can use the same existing code to deploy on Kube, on a simplified Kube, this serverless containers offering. The only difference is that they can take containerized workloads and move them seamlessly. This is not exactly true, because we have this ecosystem fragmentation happening, because the offerings are slightly different, not exactly similar. So we've chosen containers as the lowest common denominator of the stack, because we assume that we could port them, right? We assume that once you package the application, you could run the application anywhere in the same way. We expected containers to fulfill our multi-cloud dream. But in reality, deployment modes and configuration of the applications, especially running on some of these services, are very, very different from each other. And this has fragmented the ecosystem, which is not a healthy thing probably, because all the cloud providers are customizing all the solutions together. Which brings me to my next slide, last one of the talk, which is we're seeing more and more Kubernetes as a platform. And we're seeing that the main drivers of Kubernetes as a platform is multi-cloud, especially in large companies. They will choose Kubernetes as a platform in order to avoid vendor lock-in, to increase the freedom of choice of CSPs. And they say, okay, we adopted Kubernetes, we're multi-cloud, that's not a problem that's a great thing for us. And multi-cloud is great because it allows us to reduce vendor lock-in, to connect the cost, to reduce the cost. But the problem is, if you do this, the portability of multi-cloud of a single container is very high, but of a package application and the dependencies of the ecosystem is not as high. So Kubernetes gave you basic portability. One thing to think about, the serverless solutions that are built upon Kubernetes right now, they're very, very powerful, but they tie you in more within the ecosystem because they're slightly different. What the industry would need is probably a transparent open source layer that is just not there at the moment. But new services are coming out, Dapper, Knative, are going in the right direction, I think, as well. So overall, I hope you found some interesting, you find my talk interesting. I hope you like that. I'm not sure how much time we have for Q&A right now, but thank you for coming. I hope that you will remember the options that you have to run containers.
All right. Thank you, Federico. It was much appreciated. Actually, you left a reasonable amount of time for Q&A. I think we've got about 6 minutes to post some questions. So if you got your questions, make sure you get them in now. I think one thing I found interesting early on was when you were looking at the timeline of containers, right? And it started in the 1970s, and I found it intriguing that it looked like it didn't necessarily evolve much until about the 2000s. Is there any reason you can think of why that was the case?
Because there was no use case for that. Simply like the
Mm.
industry has not found the right level of use case because we never needed microservices. Containers run explode when we start needing microservices. When we start packaging our big monolith into a lot of small components, then Kubernetes, then containers suddenly are the response to, oh my God, we can do this, it's super easy, I'm just gonna go for it. And Docker comes at the right time because Docker is really the enabler to all of this. Docker has great marketing, great technology, and when that happens, usually you see enormous attraction. Enormous traction.
Okay. Well, looks like we have a question from Augustus. He asks, "It's worth sorry. Let me just rephrase that. Is it worth it to use K3s managed services for production systems, or leave it for edge computing cases?"
No, definitely. It's an interesting question. So I think that production system, running it in production is definitely a valid option at this point. I think it's a very common, I think it's a niche service offering, I think right now, but running it production at the right level of maturity, especially if it's integrated in a broader ecosystem, it's worthwhile option, I think right now. I
Okay.
would argue.
Looks like we've got a question from Christianus. He asks, "Is there any self-hosted turnkey Kubernetes management solutions that you're aware of?"
Yes. So there's plenty of those solutions out there right now. I would argue that the most famous, well, the most famous are OpenShift. OpenShift on Red Hat is the most famous self-hosted solution. I haven't covered that right now, so we haven't covered that because it is it's a vendor offering, and because it's typically aimed at on premises. AWS has a managed OpenShift as well as a service, which we haven't covered in the cloud, so you can deploy that there. They're very powerful option. OpenShift itself typically they go beyond the container offering, the clusters offering, and they start adding features that are somehow integrated with enterprise needs. There's lots of others as well, wide available. My talk is focused on cloud because I think that most people will think about cloud.
And to that end, Augustus comes in with a cloud-related question. In terms of cloud providers, is it are there some unknown ones that you think are worth checking out, or is it just worth sticking with the popular ones like GCP, Azure, and AWS?
So, no, I think that it's a very interesting question. So I think that
Mm.
the major cloud providers are definitely more feature complete than others. And I think that especially if you're running your application at a global scale and you need to deploy across multiple regions, the global CSPs are way better positioned than anybody else right now. But if you're a small company and you want to deploy to a specific target market, then there are smaller players that can help you with this. So, for example, the smaller players that can help you simplify other concerns, compliance, data locality policies, controls as well, and allows you also to, if you want to reinvest in smaller cloud provider that can target specific needs. Quite a few cloud providers are based in Switzerland, for example, and they have significant claims on data locality and promises on privacy of the data as well. Other providers are based, for example, in France and Germany. A lot of those niche players maybe are not as feature complete, but you can have a direct relationship with them, you can talk to them, and they typically have a compatible API surface is another key. So I've seen a number, this was true for S3. So for a number of years, I've seen enterprise offerings that mirror S3 API surface and lets you talk with that. I wouldn't be surprised if at some point we see enterprise offerings or offerings for smaller cloud providers that mirror the API surface of AKS, EKS, and lets you deploy on Cube, but locally or on different providers. So that's another option as well. And Anthos and the overall direction of travel will match that as well because will allow you to deploy on whatever Anthos run.
Okay. Wow. some insightful answers. Thank you very much, Federico. I think we're about up with the time, and it looks like we did get through the main questions that we're showing. So thank you to everyone viewing and those who posted questions. And big thanks, Federico, who, without him, this talk wouldn't even be happening. We had some great insights, and it was a pleasure to have you on.
Thank you, folks. Thank you for coming. Continue is hiring. So come and connect with me on LinkedIn. Thank you for the invite.